Buongiorno, buongiorno, benvenuti a tutti. Let's switch to English. Good afternoon, everybody. Thank you for being here today with us, and welcome to the Young Manufacturing Leaders Main Event 2022, the annual meeting organized by the Young Manufacturing Leaders Network. I'm Fiona Ciacalli, and I'm the host, your host for today. And let's talk about the network. It's an open initiative. I think everybody knows this, but let's just remember. It's an open initiative for students, young workers and professionals interested in a career in the manufacturing sector that was founded in 2020 with the support of EIT Manufacturing. It counts today more than 520 members from more than 34 countries all around the world. The network counts today 9 partners that run 8 city hubs around Europe, and the partners are Politecnico di Milano as leading partner of the initiative, Chalmers University of Technology, Czech Technical University in Prague, IMH Campus, University College Dublin, University of Porto, Federation of Estonian Engineering Industry. This is in German, it's difficult for me. Technische Universität Braunschweig, and World Manufacturing Foundation, of course, which yearly organizes the World Manufacturing Forum. So to open up, I first of all want to thank you everybody here who are here in presence today with us, but of course all the people following us online with our online streaming. The venue is amazing. It's the Porsche Experience Center in Franciacorta, and I think everybody of you had the chance to get a little bit around. I will now leave the floor to Professor Marco Taisch, Scientific Chairman of the World Manufacturing Forum and Professor of Digital and Sustainable Manufacturing at Politecnico di Milano. Thank you so much for your presence. Do you have the microphone? Yes.
Yeah, I have it. Yes. Thank you so much, and thanks for the invitation. I'm very, let me say, excited to be here today. This was an idea which, as I said, started in 2020, but the idea was one of the main pillar of the creation of the World Manufacturing Foundation. We are discussing about the future of manufacturing. We are trying to understand how manufacturing can be or could keep to be the peacekeeper of the world. This is how we started the World Manufacturing Forum in 2018, manufacturing as one of the most important peacekeepers in the world, because you create jobs, you create innovation, you create wealth, and therefore through this people have a job, and it's a way to create the peace all over the world. But in order to do that, we need to not just to work, as you have seen this morning, on the strategies that the company should put their effort in the future. We don't work just as suggesting to policymakers what we think should be done in order to create the best environments or the best environmental regulation or regulation. But also since we look into the future, we need to discuss with the young people. The reason is that I was asked to prepare a presentation on the manufacturing, and I put manufacturing and internet in Google. Okay, the future of manufacturing. I put future manufacturing images, right? And what came was responded by Google was a very old factory with a lot of smoke polluting the environment. And I said, wow, if this is what is perceived by the network as the future of manufacturing, I think there is something wrong here. And a lot of people, a lot of cities are still thinking that manufacturing is polluting, is dark, is not nice to work in, is not a nice environment. Engineers are something that you should keep away for your life, and something, all this kind of
Everybody's
jokes.
laughing.
I don't know whether they are engineers. Maybe they are, but they didn't understand my joke. Okay, that could be another reason for that. Anyhow, there are 2 engineers here, maybe more. That's where the idea started from. So let's try to create a different image of what manufacturing is, and I think this is the goal of the foundation. But then Diego, the president of the foundation, will better address this topic, I'm sure. That's how the network started. I'm very impressed about the number you gave in terms of members here, because this is you know, they used to see the foundation as just a, you know, a launch seed, but that it's up to you guys, ladies and gentlemen, young ladies and young gentlemen, to keep it running, to keep it alive, because this is something for you, it's not something for us, right? It's something for your society and for your future. We are here to support you, to help you, but that's you need to keep the leadership of this initiative and do it for you. I'm also very happy that in the meeting we had this morning with the UNIDO, we discuss with you about this initiative, and also you were curious to learn more, right? That's the reason why there are two representatives of the United Nations Industrial Development Organization here listening to do, so please be careful. No, just of course I'm joking, because I think this is it's a great opportunity for us. So let's have a good meeting, and you could trust in us. You can look for any support of us. I'm sorry I have to leave because there is another event in parallel to this, so I need to be. I mean, we haven't been invented cyber physical system, but not for people yet, right? So there is only one, but one is enough. Okay. Thank you so much. Thank you.
Thank you. Thank you. Thank you so much for dedicating your time to us. Thank you. So now we leave the floor to Carolina Torregrossa Gallo. Did I say it well?
Yeah.
Great. Education Program Manager at EIT Manufacturing. So this is all yours, and make us dream.
Okay, so first of all, thank you and welcome to you all. I'm really glad to see that we have the full room. And congratulations to the organizers of the event and well, the people that's behind this interesting project that you will be listening a little bit more about in the rest of this event. So for now, I will be introducing what is EIT Manufacturing. I hope that many of you know what is EIT Manufacturing, because you are many there YMLers, or what we call the young manufacturing leaders, and I expect you to be ambassadors of EIT Manufacturing. So what's its EIT Manufacturing? EIT Manufacturing is a knowledge innovation community funded by the European Institute of Innovation and Technology and the so-called KIC. But why do we need, KIC in manufacturing? So here are some numbers. In Europe, we have more than 2 million companies, which many are SMEs, small, medium enterprises. We generate a turnover over 7 trillion euros, and most importantly, we generate employment for more than 32 million persons. So what's the objective of EIT Manufacturing? It's that global manufacturing, it's led innovation, it's led by Europe. Why? Why is this important? Okay, so we have many challenges in the manufacturing industry. Here you see some of them. Manufacturing in Europe needs to become more digital, so hence digital transformation. We need to become more green and more sustainable, hence sustainability, and you have seen the Green Deal and all stuff. And all in all, we need to remain competitive. So we need to keep the right environment for entrepreneurs to be able to turn their ideas into products and services. Okay, so this is why EIT Manufacturing is targeting to lead manufacturing innovation in Europe. How do we do so? Okay, so we try to put together education, business creation, and innovation so that we can lead this change, that we can put innovations through the market and upskill and reskill people so that they are prepared for the changes that we are constantly living. Also, we have a special focus on what we call the Regional Innovation Scheme that give a special focus, let's say, once again, I repeat it, sorry, to modest and moderate innovators according to the European Innovation Scoreboard. Focusing a little bit more on education, so that's the reason that we are here. In education, inside EIT Manufacturing, our objective is to connect people with skills. We have seen today in the previous interventions in the forum that there is a huge lack of skills, there is a huge gap, and we need to work with that. And we need to help people to upskill and reskill so that they are able to overcome the new challenges. But not only that, we need to attract more young people. We need to attract the youngest generations that we have here today. And that's why YML is one of our core activities that we have been funding for 3 years now, and that we will still be funding for another year. So just for closing my presentation, and I invite you all, but especially the YMLers, to take this huge opportunity you have and make it useful. You are here sitting with top people in the manufacturing industry. You have the opportunity to network among you. So take the chance and make a difference, because the manufacturing industry needs you. So thank you very much and enjoy the session.
Thank you, Carolina. For him, yes. Welcome on the floor. So I want to say welcome to Diego Andres, President of the World Manufacturing Foundation, and he also is here to tell us something. So you have the mic and the stage is all yours.
Thank you very much. Good afternoon, everybody. I do not have slides, actually, because I would like, as Marco suggested, to have a discussion with you rather than a presentation, because I think you can be and you are part of the solution. So first of all, I was very, very happy when I learned about YML. Again, because for young manufacturing leaders to understand and being together with such a vision, such a mission, to me, it is absolutely very important, and I'll tell you why in a minute. So first of all, just to understand who do we have in the room, could we just like raise hand, like who is from the academia? Okay. Who is from the industry? Okay, and institutions? Okay, so academia is like number one, and industry is number two. Okay, so basically, where is the problem? I mean, I tell you just a little bit of story where I come from. Like 10 years ago, I was heading the what we call the group of mechanics and mechatronics companies in Lombardy. And we launched that investigation to really understand what was the perception of industry by the different, let's say, class of people, right? And basically, our industry, the mechanics industry actually, in Italy was named under like metalmeccanici, okay? So we ran that investigation, and the result of that investigation, and we asked for, of course, young people, but of course we asked to families, we asked to teachers, we asked, of course, for employed people, for employers, all of that, right? So basically, the result of that was actually a little bit what Marco was referring to you before. So if I can like summarize with one image, as it was mentioning images, would be like, you know, modern times from Charlie Chaplin. You remind that guy to get trapped into the big gears, oily and dark, right? So really the images that was like really the words, and we put all together the words, you know, in that nice pictures with the more the word is mentioned, the more that the word is big. So really the words was like unsafe, dark, fatigue, and unpaid, I mean, not paid well, and risky, and all of that, right? So, and while, I mean, I was running my own business, and I was sharing with a lot of other entrepreneurs, we're just really trying to do our best to serve, you know, the digital transformation, invest so much, transform our factories, and actually, we were seeing those places as to be really like fantastic opportunity for everybody, in particular for young people to express and really have an impact. So there was really a big gap inside there. And so we started that process. I mean, of course, every process started to make a photography, understanding our things, and then we started this process of basically repositioning the, let's say, the image of the industry. And I think that was like very well taken, because we had a lot of like support. I mean, now it's I don't want to put it too much into the Italian context, because that's not what's not supposed to be. But basically, we had a lot of support from media, and so we really did like a lot of very good things. I mean, started from a new name, which was Mechatronic, but let's not focus on the name, but really because we really had to change the storytelling. So we went to theater, we went on TV, and we did like this pubblicità progresso. I don't know if anybody of you know that, but the Italian one knows what it is, because of course it is a social problem, because if the operaio, which is the operator, the technical operator, yet today, and in Italy, it's been singing to the. If you take a pyramid and you move it around, is really at the bottom. So how can you expect teachers and families, I mean, to push for their kids to follow like a career which position themselves somehow at the bottom of the pyramid? So it's all messed around, right? And so we really started with that process. And of course, I mean, cultural change takes ages. But again, what is the result is that yet today there is a big gap. If you take the number of NEET, so people which are not employed and not in education and into training, the average European, and I was just reading this morning, is 13.1%. With a goal for Europe to be, I think in 25 to be less than 9%, but Italy is at 23.1%. There's a huge gap, and people are desperate, companies are desperate to find new people and new skills. Let's take away the job shortage that we have in the past 2 years, which is, I mean, it's really like very much a contingency thing. But if we take that spike, yet today, I mean, there's a lot of young people which, I mean, are sort of lost, and companies which are in desperate search for people, competence, and all of that. And you know, the challenges that industry has now today are such that without you guys, without the young people, because I mean, it's not about the energy, but I mean, the digital transformation really takes a completely different mindset. So the industrial transformation without you cannot happen. And if you do not see that the attractiveness part of that industry, then we're not going nowhere. Okay. So I really want to build up that sort of context. And again, you know, I was heading this European organization. It's called CIMET, and we were talking about directly with the Commission about these things, and we're launching the image. And of course, I think in every country it's a little bit different, right? The perception of industry. For example, if I talk about Germany, for example, Germany as a model of really very close working between companies and schools, and in particular technical schools. So that's problem. It's less perceived. So when I was speaking with our colleagues in Germany, this is less perceived. In other countries, that is more. So the thing is, I mean, I wanted to start, I mean, from that pictures and from the fact that without the new generation getting part of that, of the industry and helping transforming the industry, that we're doing all this for nothing, okay? So, and the fact that you are here and you are part of young manufacturing leaders means that you really understand that very well. And of course, I mean, you see the real picture of how attractive an industry like this can be, and the impact you can actually have in such an industry in working with us. So, said all this, I would really like to take this last like 8 minutes, possibly to really have a conversation with you, and really like. If any of you in particular, I mean, the YMLers, as you call them, I like it, and has any perspective on that, why do you think industry is yet seen, and maybe you have a different view, and we welcome all kind of views, because again, I think we really need collectively to tweak that out. Otherwise, it will be a real problem, like in the next year. So I would really open up. What do you see? Why is that?
We can ask to somebody, maybe someone.
Oh yes, it's really up to, especially to the youngers. But I mean, it's open to everybody. I mean, because I'm really interested if we could come up with like 2-3 actionable points for you and for us eventually to put.
We already have a question.
Fantastic.
This is for you.
Yes, thank you for your question. My name is Greta. I'm from Chalmers University. I read a statistics that said that kids today in Sweden, this was made, have no view what industry is. So not that they have this very negative of like dirty, loud, etc. More that they have no picture at all what it is like. So I think that maybe the pictures we see is like Charlie Chaplin or like those old movies, but we never see it in school or even before. So I think it's like an unknown world that so many don't know about. So I think one suggestion would be like more study visits, or like, you know, have it in the school curricular in some way very early. I think you can make this very playful as well with young kids. How do you build something, you know? Let's build a factory for, I don't know, hamburgers or something like this. Yeah, so that was just a suggestion. More study visits for young kids already to actually get a picture of what industry is.
Thank you. I think you said something which is very important, because probably, let's say, 10, 15 years ago, there was probably yet that image a lot. And now it's even worse, in the sense that even the newer generation, they even don't know about industry. So okay, so it's even you're like creating even more distance. So, and I can tell you an example of your suggestion. I mean, I tend to go and talk a lot with the kids of any age and bring them into the factories. And when I do that, they go out with eyes like that. So it is absolutely true that creating that gap. But you know where the problem? I mean, I don't want to generalize, of course, but it's usually the teachers. The teachers, when they come in, and I see the kids, they have like bright eyes, and the teacher, it seems they're not. Okay. So again, it's really when you want to talk about with the kids, I mean, you will also need to touch the touch point with the families and with the teachers, because it's basically where the both messages comes. I mean, now the world is a little bit different because the kids, they learn that they grow a lot, of course. I mean, they hear the family environment, the school environment, but they also a lot, I mean, the social, social media, whatever is that. I mean, that's very powerful. In fact, with the national organization, we are running that program where we basically have some sort of like influencers, okay, but I mean of their age, okay, which we use them to talk about industry. So they talk with in completely different language, completely different tool, which I mean they don't belong to me. I wouldn't even know how to start. But if I go out in to the youngest and I tell about industry, I mean I come from industry, so I have like a bias, if you want, right? If they hear from different angles and with different tools, then we can be more powerful. Yeah, but I think you have a good point. Very good. More. Thank you.
I wanted to ask you a question regarding the like more academia-related part of maybe future workers. I talk about Italy because I'm from this country, so I know more about it. Do you feel like these, I mean, less interest people in working at the operator or lower classes in the industry is also due to the fact that a lot of people, especially during high school, when they switch and go to university, they drop out, and maybe they should go to like there should be some incentives to go to ETS. We have the ETS in Italy. There are post-high school technical degree. And do you feel that somehow for the industry telling people to go that direction should be a way to increase the...
Sure. But your question is very clear. And I mean, there's a couple of things. First, I was speaking about the operator, but actually the operator do not really exist anymore. Okay, if you come to our factories, I mean, people are managing complex, autonomous, semi-autonomous systems. It's quite a sophisticated job. So there's no operator. So there's very little operator. So the job are changing extraordinarily. So I think that's where we think. So if we still think that operator, it's yet existing, but it's going to be less and less. So that job is really changing. So with that in perspective, I mean, ITS are fantastic. I mean, we do a lot of exchange with the ITS. Most of the hiring, we do them through ITS. But the thing is, because teachers and because families has that perspective of manufacturing, that they will not push for ITS, okay, and for technical studies. So technical studies, not technical at the STEM, not at the university, but is the technical, really like high school, if you want to name them, they are still very, very little attractive. When I speak with them or even with family, it's really about A class and B class, and that's positioned as a B class. If we do not like really change that, then we're still gonna have. But again, ITS is really doing very, very well in Italy, so we're super happy about that. Of course, it's a very different order of magnitude compared to the German system, for example. But I think it's one of those initiatives which is really running well in Italy, and we should really like push more and more for that.
Okay.
More ideas on or perspectives.
We have another one over there.
Hey, my name is Rahul, and I'm from Chalmers, Sweden. And I think one thing what we should really do is follow best practices, like we do in manufacturing. If we look at the industry worldwide, I think the most attractive industry right now, if you ask the younger generation, they always say IT industry. Why is that? What is the IT industry doing different that the manufacturing industry isn't? I think there also we should follow best practices. Like I have a close friend who works in one of the leading software and gaming industries, and the first experience that he has is, he enters the office, and the office is, it's bright, it's fun, there are gaming rooms, there's napping rooms, there's almost anything you can think of. But you enter a factory, what do you see? I think we need to create the environment we want others to work in. So I think we need to create or follow best practices in the industry. So that's one suggestion.
That's a very good point. And actually, I mean, when you're thinking about, you're naming like IT and you're naming manufacturing, right? You're naming them as they are like two different industry. But at the end of the day, if you're looking like manufacturing as of today, the IT part of manufacturing, it's quite significant and has been touching a lot at the process right now, but it will be touched more and more the evolution of the offering of the products, right? So there's going to be way more IT in the regard. And again, I agree. I mean, the environment of a Google-like company, if you want, it's somehow difficult to replicate into manufacturing, even if it's not necessarily true. And they said we have examples, I don't know if you ever visited, but there is the Renzo Piano factory of Pirelli in Italy, which I think it's quite an example. So, I mean, of course, it's not so easy to replicate that overall, but I think the attention for the environment, I think it's for sure a very good point. Thank you. More?
I don't think we have. Maybe I have one. So I was wondering if the factory environment wasn't able to communicate his own environment to the other. So that's why maybe the vision we have is still the one of Charlie Chaplin. What do you think about this?
No, you're absolutely right. I mean, people from the manufacturing, they've always been, busy in doing rather than telling, right? And now you see a big gap, for example, for the large companies. I'm not going to mention any, but I mean, they've been learning to communicate much better. But this is, at the same time, is creating a bigger gap. We'll be speaking about that this morning between small companies and large company, how digital and the adoption of digital can really create a bigger gap. Even in that regard, as I do believe competition for talent will be the key competition in the next 8 years. If you're a small company, if you're not able to have a nice environment, really be able to communicate well, you're going to be less and less attractive to the youngers or in general to the talents than the large company will be. So that's another big issue we're going to have in front. And again, I think this supply chain, which is the topic of today, when we see supply chain, when we see inclusivity, sustainability, all of that, it's really the role for the larger champion, which are driving the supply chain, to bring in all these best practices along the supply chain and the value chain. Because if those small, medium size, they do not thrive and they do not thrive because they're able to be attractive and get the talents, it's going to be a problem for the whole value chain.
Thank you very much. So I thank you, both of you. So we ended our time for the moment, but we have, first of all, a big round of applause.
And let's keep open this conversation. Really,
it was very interesting.
Reach
yes.
to us if you have anything, because this is something we're struggling in, and for sure it's going to be something, another area where with the foundation and the YMLers will be able to cooperate more. Thank you.
Thank you. Thank you again. Thank you for being here with us. So now we move to the first awarding ceremony of YML contest for the 2022 World Manufacturing Report. Thank you so much. So please welcome on stage Federica Cervi, PhD, Politecnico di Milano and World Manufacturing Foundation. So the floor is all yours. You can take the mic.
Thank you very much. Yes. Okay. Is there the slider? No.
It was here.
Sorry,
here
I didn't see.
Yeah, no worries.
Okay. Great. Yes, okay. Now we are going to present the winners of this contest. If I can move the slides. Yes, sorry. Okay. Yes, actually, first of all, our main goal of this contest was to try to explore how the YML, why does it works? it changes the, alone.
You have to point over there.
Yeah, but it's not okay. Okay, this okay. To see how they perceive the main trends that are driving manufacturers to rethink their supply chains in this new era, okay, where sustainability in terms of economical, social, and environmental way are relevant as key drivers. And then we want also to evaluate how YML would perceive digital technologies as main supporters for the redesigning of these supply chains. And actually, what we evaluated were the creativity of these students and in general of these guys and ladies, but also the topic understanding, so whether they had understood what we were dealing with and how to be able to be integrated actually in our report. And then obviously the overall structure and style, so to share their ideas. So we wanted to see whether they had an original ideas, they were able to identify potential case studies and provide us with a wow factor so that they could be brought into our report. Then we try to ensure that they were adherent to our report and be direct and concise, direct to the point, actually. So actually, all these winners had the opportunity to see their case study being published in the report. So if you look at the report, you can have a look over all all these case studies. And now let's move to the name of the winners. Okay, first of all, Elena Fernandez Calvo, an R&D trainee from Schneider Electric, with the case study entitled Smart Warehouse, a place where all data is connected. Is there? Okay, perfect. Great, congratulations.
Thank you.
Okay.
Sorry.
I'm sorry. Okay, congratulations. Okay. Then Paulo Victor Lopez, PhD student at Chalmers University of Technology, Production Systems and Maintenance Research Group. Okay, with a case study entitled Data-Driven Digital Twins to ensure resilience, sustainability, and technological continuity. Congratulations. Okay. I'm sorry, but I don't know why it's okay. Okay. Okay, perfect. Thank you. Then, next winner is Danuzuya Pachimutu. I hope that the pronunciation is okay. Okay, sorry. Congratulations.
Thank you.
Okay, next winner is Loic Ronin, PhD student, Codobio project, Politecnico di Milano. So congratulations. Okay. Okay, congratulations. Then we have Luca Torelli, EMEA Supply Chain Transformation Project Manager from Exilo Luxactor. Congratulations. Redesign an integrated, sustainable, and digital supply chain to enhance competitiveness. Exilo Luxactica case study. Okay. Congratulations. And great. That's all. So congratulations to all of you. and also all the other YML that participated and gave lots of interesting ideas. So really thank you to all of you.
Ok, abbiamo finito? Sì, già, finito tutto? Abbiamo ancora 4 minuti. Oh, sorry, we still have 4 more minutes. Okay, you were so fast. Okay, so we finished our award. So we have another interesting speech right now. So I want to leave the floor to Valeria Tirelli, President and CEO of Hydro.
Hydro, yes.
Yes, great. So that's yours, the clicker?
Is here.
Here.
Okay, so hello everybody, nice to meet you. I'm very happy to be here today and share some ideas and experience. I'm CEO and President of Hydro. Hydro is a small, medium Italian company based in Lombardia, and I'm also ambassador for Women 3D Printing, the international network promoting the presence of female in the additive manufacturing. But first of all, I'd like to share with you my passion. My passion for technology, my passion for innovation, and the possibility to create innovative products for the future, to change our future in a sustainable way. So the company, as I said, was founded more or less 40 years ago by my father, so it was a family business. But a few years ago, we introduced a new technology. And thanks to this new technology, last year, my company moved from a family business to be part of an international group, Desktop Metal Group, that is leading in additive manufacturing. So this was an incredible journey for us. But everything started from this technology, so 3D printing or additive manufacturing. I'd like to ask you, how many people do already play with 3D printing in the room? Okay, some of them. This is an incredible technology. And why I'm really passionate about this technology? Because we are able to produce what we need, where we need it, and when we need it. This is something completely new compared to the conventional manufacturing. Disappeared. Maybe my message was too strong. So let's try to explain you better. So thanks to this technology, now we are completely changing the way, okay, thank you, the way of manufacturing. Okay, we are here. Why? Because compared to the conventional manufacturing, with 3D printing, we have less constraint. And we have also a new mindset to produce part and design part with 3D printing. For example, what we need in our company, when we started to use additive manufacturing, at the beginning we used this technology for making tools and some support for our conventional production of hydraulics parts, mechanical components. So as all the other industry, we need some tooling, and normally we purchase from outside. We design it and ask it to our suppliers. But as in every industry, there are a lot of delay, cost, also for making tools. So we decided, why we don't produce the tooling inside? And thanks to 3D printing, we started to solve our daily problem. So we were completely amazed by this technology because we're solving problems, very simple problems, but that were necessary to overcome to produce our conventional parts. So we start to think why we can not use this technology to produce real parts, functional parts. So from polymer printing, we moved to metal 3D printing, and then we started an incredible journey. We decided to invest in this technology, creating our own department with metal 3D printer, with engineers, and with post-processing. So all the phases that are needed to produce parts. And then we started to be part of different groups, international groups, working on the definition of guidelines and standards for the qualification of 3D printing. Because it's a new technology, there were no standards. So a lot of industry like oil and gas, aerospace, they are not able to adopt a part if there is not the qualification. So we were invited to join this group, and we helped a lot to create these guidelines. And thanks to this journey, we also understand that technology like 3D printing is very useful to produce the part where are needed. Maybe you know the concept of distributed manufacturing. More and more now is necessary to produce the parts not in the same place where the parts are designed, but for example, in oil and gas, they need parts in, I don't know, South Africa, in Singapore, in South America, but the engineering is made in Europe. So thanks to 3D printing, now we are able to design the part here, just send the file, and produce a part where it's needed. And when it is needed. When there is some supply chain issue, like in the last years. As you know, there was a lot of big troubles from raw materials, delay, and so on. And then also in Hydro, we started to print our parts when we need it, because the waiting time from our supplier was very long. Again, thanks to 3D printing, we solved a lot of problems, and we are able to create innovative parts. But just few words, maybe you already know what is 3D printing. Okay, I think everybody is already full after lunch. But you know, additive manufacturing or 3D printing is a manufacturing process layer by layer. This allowed us to change completely the approach of the manufacturing, because we have a lot of freedom in the design, we have a lot of freedom and less constraint compared to the conventional manufacturing. What is really necessary to use, to take profit of the benefit of this technology is to change the mindset, adopt a new approach to the designing. Exactly, thinking outside the box. And you are the young manufacturing leader, so for sure you have no constraint. You are really open, and you can make the difference in this technology. I'd like to share you some examples from my company. This is a very conventional hydraulics block. Maybe some one of you have already studied fluid dynamics and hydraulics. So this is a piece of metal with some holes and channels inside, made in the conventional manufacturing, so CNC machining. A few years ago, a customer came to us and he asked us that he has a problem with this hydraulic manifold because it was too heavy. It's 5 kilos of aluminum, but for his application, he needed a very lightweight hydraulics block. But no other conventional manufacturing methods were able to make lighter, because this is already in aluminum. And the customer asked us to keep aluminum, so the same material, keep the same, say, base, and of course, the same function. So thanks to the new approach to the design, we were able to design this part with additive manufacturing and reduce the weight from 5 kilo to 1.3 kilo. So it means 75% weight reduction. It's impressive. It's completely impressive. But as you can see, the approach is add material and not subtract material as in the conventional manufacturing methods. And thanks to the fact that we are able to add the material only where it is needed, we reduced the weight, we kept the same function, and also we improved some performance inside this hydraulics block. And thanks to the fact that we are now able to work and use additive manufacturing, this technology opened a lot of doors for our company, especially in new sectors like aerospace or, as you can see here, helicopters. Because lightweight, as I said, is one of the benefits of this technology, and for sure, what is flying needs less weight. And last year, we were qualified by Leonardo Helicopters as suppliers for additive manufacturing. This is a very good step for my company. Again, from a small business to be qualified by Leonardo was a huge process, but at the end, we were, I say, quite lucky. We passed all the tests, and now we are producing metal parts, critical metal parts, flying on helicopters. Another big step for the company was this block. Is again another hydraulics block. And as you can see here, what is amazing is the design. The design completely changed compared to the conventional manufacturing. we were able to design this part with topology optimization. I'm sure some of you already know this term. And we changed the approach. And we were also able to design the parts and reduce the weight and the size, the dimension. This was installed in one of the racing boat that you can see, one trimaran, that was also the winner of last competition in the Mediterranean Sea. I cannot say that maybe thanks to our blogs, but at the end the boat was the winner. Another example is coming also for Politecnico di Milano, so maybe some of you already know this team. Is Dynamis PRC, is the Formula E student, so the electric vehicles designed and built by the Politecnico di Milano. And also for this team, we produced some parts with additive manufacturing when they needed, especially during the period of racing that were quite stressing. And we were able to print and produce the parts very quickly as the team needed. Oh. Something again. I think okay, perfect. Okay, I think we just, okay. Last point that I'd like to share with you, still from my experience, is something that gives us another benefit of using additive manufacturing, is the sustainability. You see here an example of, again, an hydraulics block. Sorry, I'm quite on these sectors. You can see this is the conventional parts made by two blocks. You can see one gray, one gold. This is the conventional manufacturing. The manufacturing method is casting mainly and CNC machining. And then again, we were able to design for additive a new block, reducing the weight, more or less in this case about 30% of weight reduction. The block was also tested in CNH industrial test bench at 1 million cycles. So the technology proved that the mechanical properties are good for this kind of technology and application. But what was very interesting is that we performed an LCA, and I know that some of you already know because there was a contest about LCA, and the comparison from the conventional manufacturing, you see the top on your top left, the LCA showed the LCA made on the conventional manifold. We made the comparison between the conventional manufacturing to the 3D printing as it is, means without design optimization, and the third one with design optimization. And you can see that there is an impressive reduction of CO2 emission. Of course, there are some assumptions, so I don't want to say that the model is perfect, but the message is clear. So thanks to additive manufacturing, we consume less energy, and at the end, we have less CO2 emission. So I think the message is quite clear. We have a lot of benefit of this technology. Another example, again, about sustainability, is the possibility to recycle material. This case is wood. So wood from the furniture industry or wood industry is recycled, the waste material, and we create a new powder. The powder is used in the 3D printer, and we are able to create some parts, like this guitar. And as you can see, the guitar is real. And it's very, very, very interesting. So another message is that with 3D printing, we are able to recycle obsolete parts or waste material to create new objects, to give a new life to old parts. My last thing is about, a bumblebee. Maybe you already know. The rules of engineering say that bumblebee cannot fly because he's too large, his wings are too small, but the bumblebee doesn't know the rules, so he can fly. So the message is, you are free without any constraint from the conventional manufacturing and the conventional rules of what we are always doing. So please, don't be afraid to open your mind and to give a lot of contribution to the future, because you have to know that everything is possible if you want it. So thank you very much for your attention.
Thank you very much, Valeria. Thank you very much, Valeria Tirelli, for your speech. It was really, really interesting. I loved it. And we will keep on talking about additive manufacturing, but related to space application, because as everybody knows, to bring things in space, it's very expensive. So they need to be lightweight. That's why we are talking about additive manufacturing in space application, and we will do it together with 3 members of YML network. And please, here on the floor, first of all, Alessio Fino, student from Politecnico di Torino. Where is Alessio? Applauso. Evan Winterlich, you can sit. You can sit if you want for the moment. Evan, thank you so much. And Oishin Gavigan. Did I say it well? Oishin? Okay. I tried to study it, but okay, I did my best. So Evan Winterlich, engineer at iForm, and Oishin Gavigan, engineer at Plasma Bound. So it's your turn, Alessio, and please explain us.
Okay, perfect.
Okay. You can stand, you can sit,
yes.
whatever you want.
Then, okay. Let's start off first by explaining what is a focus group, because what we did is a focus group. It's basically, we find a topic that we find interesting, and as simple as that, that we think requires more deepening, more research, like that we want to explore. So we assemble a team, and we give to this team the means to deepen the research. Like we give them the possibility to talk with experts, we give them the possibility to access material and papers we offer, and this is pretty much what it's supposed to be like. Simple enough? Well, let's get to our case. Basically, we started doing some research about applications of additive manufacturing, and since we are young manufacturing leaders, we looked further in the future to space manufacturing, and we looked a little bit in the research, and what was very, very interesting was to find first that there is a ton of material, there is a ton of knowledge already in place for space manufacturing, and most of this knowledge is about additive manufacturing. The first question was why? Mostly because additive manufacturing is still in a deep developing space, the deep developing stage here on Earth. It would be quite crazy to bring it to orbit or to another celestial body, but as we found, there are some benefits. The sustainability, the vertical integration of processes, the fact that you need only one machine to complete a part. In most of the cases, in some cases you need post-processing, but we'll deepen this in the report, because at the end of the purpose of the focus group is the production of a report. Well, to get more in depth into this, we started asking ourselves some questions. First, the effect on the space economy. This is something quite huge, and the technical challenges, because it's a very hostile environment, space compared to Earth, and it's not that easy to, it's not that easy as popping out and blasting an additive manufacturing machine in orbit. Okay, we put ourselves some goals. First and foremost is to explore the role and the challenges and the opportunities that these technologies would bring to the space economy and to what is set to become a really big market in the next decades. And we did it by dividing the focus group into 2 teams. One deepened the possibility of having a closed loop in terms of supply chain of goods for the additive manufacturing machines in orbit. And it's quite interesting because it's a really big path in the life cycle of the production processes for space economy, and the possibility to have a fully sustainable manufacturing sector in space in the future. And the second one was closer to application, the additive manufacturing for the replacement parts, because a lot of parts that are needed for space are critical. and in turn there is a big need for replacement parts. And if there is the possibility to manufacture those in space, I mean, it would be a very big benefit. For this, we assembled a team. And only 2 people are present today, but all the guys are working really, really hard on this. And I'm very happy about all the work we pulled out until now. I would like to thank each one of them. And let's go on. Okay. As we said before, we split them into 2 focus groups. This first one has some key points we like to deepen. At first we looked into every perspective. We wanted to deepen every single aspect of the process. Like we wanted to try to get our resources directly from space, so in situ versus resources, and to explore some possibilities of making powder or filaments or like the raw material we need for additive manufacturing already in space. And this is quite a difficult process. We examined some production processes like gas atomization, which are a bit of a logistical nightmare in space, but still we got some very useful insights from that. We thought of that this solution could improve the recycling and give new prospects for the recycling in the space environment, which is something absolutely crucial because resources are not as available as on Earth. You gotta work much more harder to get resources in space in the current situations than it is on Earth. Then, obviously, we are deepening the technical challenges that this would come. We will talk about this more with the participants here. There are some very hard technical challenges to overcome, and that's in a sense why the additive manufacturing space is not a really big thing now. Okay, then we obviously searched what do we need this for, which are the target parts we are looking for additive manufacturing space, what will we be needing up there, and yeah, also the materials and processes. It is a very important window because I'll make a very simple example. Some thermoplastics have a very high degradation rate when exposed to radiation, and this involves high-frequency radiation, but also UV rays, which in space are very, very present, especially in the solar system. Let's move on the other group. This is about replacement parts. And as I mentioned before, this is a huge field of application. Parts, it is estimated that to maintain the International Space Station for the first 10 years of life, it has took more than $900 million only in replacement parts sent to orbit. This is a huge cost, and it is one of the main points that makes the space industry still unprofitable to this day in the when it comes to getting humans on of Earth because of the safety requirements, the redundancy needed to in each step of the logistical part of getting humans off Earth. So here again, we are looking at which processes and materials are more suited, which parts do we need to fabricate. Not all of them can be fabricated because in the aerospace industry, it is very, very important to have an extremely high precision of fabrication. And it is not possible to achieve this all the time with additive manufacturing. Actually, the surface roughness obtained from additive manufacturing is a big problem for this. Again, this could bring a good economic benefit, simply because with bringing material from Earth to space is extremely expensive in terms of fuel, and also it takes a lot of people You need a lot of people to organize a space launch. And this is one of the main reasons why we try to implement additive manufacturing fabrication in orbit. Okay, this is the really the core of why are we doing this. YML is this project is about making a paper, but the core is like to forming people, the formation of people. What we manufacture are the leaders of the future, and this initiative is said to be a benefit for all the participants of the project. Why and how? Well, first, it is they have the possibility to receive consultants and information from experts of the industry, which I mean we will greatly boost their competencies. So it's a great learning opportunity for them. And also analyzing all those papers, all those topics all together, talking about these topics all together, is also quite formative. They can really get something valuable about this. Then, since the participants we're getting are from all the city hubs, we are also helping the network. We're pulling the network together, which is really what the network is about. Like communicate with other engineers and people that are involved in the network. Then there is all the part about writing the paper, writing the report, work in teams. It's all things that are learned through practice, making this project alive. Okay, my presentation is done. I will now leave the floor to some questions to our participants.
Yes, I have 2 questions for them. Thank you so much. Applausi. Do you have the mic? No? Yeah, just stay there. And this is for you. And we start with you, Oisin. So according to your experience, do you think that the current characteristics of the additive manufacturing technologies are ready to be used in space? Or do you think they need to be modified, at least partially, of course, to encounter the different gravity force?
Yeah, I think that's probably everyone's first question when they think about manufacturing in space is the technical challenges that it brings. And there's obviously a tremendous amount of different additive manufacturing techniques, and each one needs to be assessed on a case-by-case basis. So when people think of additive manufacturing, they think of using polymers and fused deposition modeling, which that's already actually been proven in space, and then the parts have been tested back on Earth. So then beyond that, when we go a bit further, there's certain problems that come up with other techniques, like base with metal or anything with fusion. The convection and the cooling rates are all completely different, so those do need to be adapted. But then beyond that, the environmental conditions, it's almost like it's an enabling factor. So you can have greater design flexibility because using techniques like binder jetting, don't need support material, you have new geometrical possibilities. So if anything, there's potentially like a new manufacturing industry. It's specific to parts that can only be manufactured in space. See?
Thank you so much. And now for you, Evan, according always to your experience, do you think that the materials currently used by additive manufacturing technologies could be brought into space environment without any risk, or innovative materials should be necessarily studied?
I think that, like Oisin said, it's more a case-by-case basis based on...
You can borrow that. Okay.
You can probably hear me anyway.
Swap it.
I think, as Oisin said, it's a case-by-case basis depending on the process and which material you're using. Polymers have been established in space, and most of the way they're printed in space, like with Made in Space by Redwire, they print PEI and ABS and polycarbonate, the same materials we print down here, and they're not edited that much. When it comes to metal printing, I think that the main issues are the microgravity and actually the process of trying to print it with no gravity. Not so much the material itself, it's just trying to get that material in space to behave as if there was gravity acting on it. I think that's the crux of it.
Do you want to add something?
I think that's most of the information delivered. Does anyone have questions?
We have just one question then. Thank you.
How will you pitch this to
Oh.
It's okay like this? You hear me?
No, they can hear it, but here it is.
Okay, perfect. Okay, the main focus of this is basically getting more people to know about this, because like we wanted to. When we found that there was so much research on this topic and how little people know about this, we found that's really staggering. So just by like publishing this paper, we could at least get more people into this. Selling this idea to brands is, it's interesting, but it was not really the purpose of what we thought with this project. We just wanted to make the industry and the world, in a certain sense, more aware of these possibilities.
I think also the sustainable aspect of it, the fact that if you're able to recycle in space, you can Airbus is sending a metal 3D printers to space where they want to collect space debris and use that to print more satellites, and that's causing that's solving
Mike.
Sorry, that's solving multiple problems with one issue.
Okay, thank you so much. Thank you for your time here, and some applause for them. Now we move. Grazie. Now we move into the session of this event called "The Future is Now: Becoming a Manufacturing Make Changer," where we will deep into the main activities carried by the YML network this year, which is called the Learning Paths. And then we will have an insightful roundtable, which will be very interesting, with some members of the YML network and EIT Manufacturing. So now, welcome on floor, Leonor Conego. Hello, Research Fellow Faculty of Engineering and University of Porto. Thank you very much for being here today with me. So I want to ask you, the first resources created by YML is a digital learning path about creativity, innovation, and entrepreneurship. So tell me something more about this new learning path. The mic. Do you have it? No, mic. It's important.
So the idea started with as wanting to cover the creativity, to deliver this to young generations. But then we wanted this to evolve to something more tangible. We did not want only to talk about creativity. We wanted creativity to be a driver of innovation. So that's when all the other topics arise, such as the public speaking, how to deliver a pitch, how to write your presentation, the life cycle analysis, so how to assess the environmental impacts when between all the stages of the product. And also then it goes to prototyping and more a hands-on approach, and that's it. That's a little bit about this learning path.
So I was wondering how this learning path is structured, so and how you developed it.
Mm-hmm. We had a limit of 30 minutes. We wanted this to be interactive and short. It is just like TikTok generation, you know, we want fast things. So we created small nuggets. We call this nuggets. And actually you can do this in one day if you want, but they are 7 different topics, and you can do it on your own path, on your own pace, sorry. So I think that's it. It has this limit, and it was an important thing is that it was developed by different partners. So we have the expertise of different entities, different faculties, companies. So I think this is a major value of this.
So what did you learn from participating in this activity? And if there is anything you would have done in a different way, if any, of course.
I think that it reinforced the idea that teamwork is the, how do you say, the teamwork generates the good work. So it was the effort of all that did this together. Otherwise, it wouldn't be possible to have so rich learning path. And I don't think I would do, we could join more entities to it, but for a first step it was a great experience.
So you have 30 seconds to tell the audience why they should enroll it.
I think we have 4 minutes more because... okay, well, I think you should enroll, everyone, enterprises who want to know more about creativity, because even if you think you are not a creative mind, know that creativity can be taught. So that's one of the things you learn in the first nugget delivered by Greta. So you should not be afraid to enter this journey of creativity. And one important thing is that you should not think about changing everything always. We can start creating small things, create a team, create a project, enter small activities that can then go into something bigger. So we should not be always thinking about changing everything and always. And then, of course, you can, I don't know, this might be a motivation for some. You can get an EIT, an official certification from EIT, and you will have fun. I think it actually, at the end, you will feel more self-confident, and self-confidence lead to innovation, lead to generating new ideas, new enterprises. So, enroll.
Thank you so much. And thank you also for reminding us that creativity can be learned and trained, of course. So you don't need to be afraid about it. Now let's keep on going with a roundtable, with an all-female roundtable. I'm so happy about this. So Leonor Conego, you just stay with us because you are one of the 5 women I'm asking to join me here on the floor. Then Greta Brown, where is she? Oh, you were drinking. Greta Brown, PhD candidate at Chalmers University and involved in the Deep Tech Talent Initiative. Clarissa Gonzalez, which is over there, PhD candidate at Chalmers University and Engineers Without Borders. Thank you. Silvia Mozzi, education developer, EIT Manufacturing. And last but not least, Anna Girardello, student at the EIT Manufacturing Master School. How beautiful having you in here. Maybe there is something wrong? I will stay here. Oh, no, c'aveva un rumorino, strange sound. Okay, so I have 3 questions for you, but feel free to chat together because this is a chat, or maybe if from our audience we have another question. I want to start with Clarissa, with you. So why should we focus on the role of young people in the making changes toward a more innovative, inclusive, and sustainable industry and society? Which difference can they make in this very difficult and turbulent time?
I think
there.
And it's on already.
Yeah.
Yes. Okay, I think that's a super relevant question and a very complex one, so I'll try in short, but please jump in, everyone. I think that in this event, overall, there's been repetitively mentions about how young people can contribute and about how we need talent and we need everyone to step up, to join the conversation. But particularly when we think about young generations in general, and when every generation has been young, there's always been an element of fearlessly dreaming and not knowing boundaries so much and being able to be creative, as right now you were discussing. But I think that what makes our generation different and the generations that are already coming right now is that there's more information than ever. We are so connected, we have so much visibility, everyone gets access to the news, to interpretations of the news, to different opinions very quick. So I think that if we take that as a strength and we also add to it the huge power that previous generations can have when it comes to mentorship, to leadership, to guiding this progress in the right direction, we can really achieve a manufacturing industry and a society that is aiming towards the right vision, that we not only talk about companies as needing to get on board on the same vision, but that we do that from a full societal perspective. So yeah, I think when we think about what changes can they make, well, I think it will be theirs to decide what are the type of changes they want to achieve.
Someone else who wants to answer to this question? Don't be afraid.
Sure. Well, in addition to that, I will say that projects that we as EIT Manufacturing try to make happen, such as the YML, really speak about how young people are starting. Maybe they always have been doing so, but today manufacturing is perceived more and more as something that can give added value to the whole value chain, to their whole life. So please continue doing so and take advantage of every opportunity that we have, not just within the framework, the competency framework of the European Union. We do a lot of things, but there is really a lot out there. Just go out and look. There are a lot of training opportunities. Of course, we try to do our best to create a community and to build and to leverage what's there. But there really are a lot of opportunities to learn and to grow. So.
Thank you. And how about attracting and mobilizing, of course, more young people to this new manufacturing industry? So maybe, Greta, you can tell us something.
Yes. Does this work?
Yeah, it works.
Yeah, so let me start with saying, maybe adapting a little bit to what we discussed right now. I think the young generation is very passionate about many different things. But for example, if we take the environmental challenges that we have on our Earth, and to show that when you work within manufacturing, you can actually contribute to, create this net zero in your country, for example, or in your company on this level, and show that you can have a societal impact, environmental, and of course economic. It all belongs together. I think that can attract many people, and then it's also about creating these kind of communities that we have here to build some kind of loyalty. And the third thing that I want to add is to also direct special incentives to the groups that historically have not been represented in manufacturing so well. So yeah, for example, women. To create incentives for women to actually want to join the manufacturing industry and also create the culture in industry that women want to stay. So I think there are many different people that needs to be involved, and creating those incentives. I guess it starts with the policymakers, but then these kind of projects and a lot of projects that EIT Manufacturing is driving, and now we're launching this Deep Tech Talent Initiative, which is also about mobilizing deep tech talents and creating this network where also companies and the talents can find each other. And also the goal is to actually create this organized upskilling platform so that you get the support also in your upskilling journey.
So we talked about, in general, about how to attract young people. But what did you attract to this, to the manufacturing field? So I will ask to everybody of you. Let's start from there to here.
Well, for me, the possibility to apply concretely what I study, and for example, I experienced this during the EIT manufacturing summer school, where there were different companies from all over Europe that presented us the real challenge that they were facing, from greater inclusiveness to the digital transition. But we weren't only a passive listener, but we have the possibility to apply in a concrete way and try to develop and implement solutions and ideas to this challenge.
Thank you very much. For you?
Yeah, I think for me it's a little bit what I said as well, to feel that I can have an impact, because manufacturing industry is such a big contributor of in our society. And I think I get also quite fascinated by the technologies that we use to create solutions for these challenges.
Thank you.
Maybe I would bring in the shaping project, shaping the next generation of manufacturing professionals. It's a project for students from 12 to 18 years old. We develop seminars, workshops, smart manufacturing demonstrators, so they put their hands on, and they, like I've mentioned before, it's important to have this tangible thing. They understand what they are doing, they create something. It's not just talking, and it's rewarding when they come to you and say, "This summer school was so great. I am so happy to have chosen this one over others." And going, for example, to schools that have lack of technology or that are socially less favored. I don't know. The proper word.
Yeah, we got it. It's perfect.
And it's rewarding in that way. I think we are really creating impact somehow. Then I think I would bring in an aspect which is design thinking. I think it's great to bring this to them, because they, from the ideation to create and to interact with creating impact with the users, and then to create, they see what is an engineer, and that an engineer is not just, they don't just create, they have to be, to create, they have to be creatives. And design thinking process is great for this extent.
Thank you.
Okay, for me, I think what attracted me to manufacturing, it was not so early on. I am Mexican, and I'm from a city that is highly manufacturing oriented and close to the border with the US. And I always considered manufacturing to be something that you would do as a repetitive job, you know, and it was not attractive when I saw it that way. But coming to Europe and being exposed to so many amazing opportunities really has allowed me to understand that manufacturing can be fun, and manufacturing can be being a leader, and it doesn't have to be a repetitive assignment where you have no freedom of thinking. And I would really like to transfer this eventually to communities where we are really missing, because I know we need the workforce, but I think the message has to be delivered in a way that more people gets the chance to come and speak here.
Thank you.
Well, for me, one of the most interesting things about manufacturing is that it's so transversal that it applies everywhere. And in this context, it's very interesting for me to be part of an organization that's a system integrator, so to connect people with competencies, skills to technologies, and to do everything that we can to help develop and foster collaborations between, for example, academia and business, to help each sector grow and learn from each other, and to do some positive cross-contamination.
Thank you so much. And I have one last question, starting from Anna Girardello, but if you want to answer, it would be great. So 2023 will be the Europe Year of Skills. So what advice or good practice would you give to boost young talents' development?
Yes, my advice is aiming for a high quality education that is able to shape people's minds, not only to be resilient to change, but try to anticipate and promote it. As a student, I recognize the importance that the education and the knowledge have. Therefore, my advice is to allow the young people to surround themselves by people from whom they can learn and with which they can share ideas and point of view, because studying will contribute, according to me, to make people passionate, curious and pioneers, characteristics that are necessary to boost young talent development. But also I think that it's extremely important to be able to adapt, to easily adapt to change and to be able to face the fast changing environment that we are in which we are living, because the transition that in which we live can't collide with inertia and resistance to change, but must be leveraged as a tool to create value and benefit.
Thank you so much. Does anybody of you wants to add something?
Yes? I can reinforce the idea that it's good that you join different groups, hang out with crazy people, even if it makes you feel like you are like a fish out of the water. Just that means you are in the good road, okay? Just keep there. You are out of your comfort zone, and that's how you're gonna develop your other skills. So that's it. Hang out with crazy people.
Thank you. Thank you very much for your time and for being here with me today. And we are almost closing. Thanks. And now we move to the last but not least awarding ceremony of the YML Sustainable Manufacturing Innovation Contest, LCA across Europe. I welcome here on the stage Lucy Helva. Oh God, you can say it. I can say that it's and teach me. Klavunkova.
I'm from Czech Republic, and it's even hard for Czech people
to say it. It's so tricky. So Klavunkola.
Hlavunikova.
Oh, Hlavunikova. Okay. So Lucy Hlavunikova, student at Czech Technical University in Prague. So the stage is all yours. That's the microphone, and you have here all you need. Thank you.
Yeah. Sorry, I'll just change hands. It is a, it's really weird too. Okay, it is a huge pleasure of mine to be here in the name of Prague City Hub and to present Young Manufacturer Leaders Sustainable Manufacturing Innovation Contest, which is called Life Cycle Analysis Across Europe. My name is Lucia Hlavunikova, and currently I'm a PhD student at Czech Technical University in Prague at Faculty of Mechanical Engineering. Yeah, so let's start with a few information about the contest. The aim was to take an existing life cycle analysis of a product or do their own life cycle analysis and then explore its own pros and cons, evaluate the whole analysis and have a proper argumentation. There has to be a few evaluation criteria how to elect the winner of the Sustainable Manufacturing Innovation Contest. Those important criteria were chosen to be complexity and objectivity, as you can see. So complexity is, I think I have different, okay. So the complexity are such as strategy of the process of analysis. I think I have different presentation, maybe, or
no.
No.
Is it different from yours?
Yeah, don't worry. Okay, so sorry. So the complexity is a strategy of the process of analysis, sustainability, and the description of the whole cycle. And then there is objectivity, such as numbers and data, which are very important, evidence-based method, and of course the sources. Yeah, so as you can already see the first winner, but it is a huge pleasure to present not only one, but we have two winners, because both of the contestants put a lot of effort to make such as videos as all of you will see. So without further ado, the first winner, huge congratulations to Oisin Thomas Gavigan. I tried my best for his project, Process Lifecycle Analysis of Chemical Propulsion Technologies for Rocket Launches. Here is your diploma. Congratulations.
Take a picture together. Okay? Okay.
Yeah, we have the video. We have the video as well. No.
Hello everyone, my name is Oisin, I'm an engineer from Ireland, and this is my submission to the Sustainable Manufacturing Contest. The project title is A Process Lifecycle Analysis of Chemical Propulsion Technologies for Rocket Launches. So in a rocket launch, a fuel and oxidizer is combusted. This generates a tremendous amount of thrust, but this process also generates emissions. So the hope is to look at the state-of-the-art chemical propulsion technologies. There's 5 fuel types, which are currently in use: RP1, liquid hydrogen, methane, unsymmetrical dimethylhydrazine, which will be referred to as hydrazine, and ammonium perchlorate composite propellant, which will be referred to as solid rocket propellant. There's 2 relevant impact categories which have been determined from the literature: global climate change and stratospheric ozone depletion. The functional units of analysis will be the mass CO2 equivalent and the mass CFC11 equivalent for ozone depletion. There's been 2 previous works on this topic. So, for the inventory analysis, all life cycle phases have previously been looked at in the 2 previously mentioned works outside of the afterburn. And for the input and output flows, these were determined in 2009 by an Otto World Henry. When we look at the emissions impact indicators for each fuel, these were calculated in 2020. They can be subcategorized for these 5 fuel types into 3 different groups: pollutants, ozone depleting substances, and greenhouse gases. When we look at the impact assessment for global warming, we can see that hydrazine-based fuels have the most profound greenhouse gas emissions. But however, total launches represent a very small amount of emissions annually. And we can also see there's a large uncertainty when launches represent a large proportion of emissions. You can see that with solid propellants there. In stratospheric ozone depletion, solid rocket propellants lead this, and the sum total represents 0.39, which is much more significant than global warming. So when we look at sensitivity analysis, we can make some conclusions. For global warming, we can see the production process is significant for some of the fuels, and that black carbon and alumina during launches due to radiative forcing are also significant. For stratospheric ozone depletion, we can see again the production process is significant for emissions, and that for launches, nitrous oxides and chlorides are the most significant pollutants. So from this we can draw some conclusions that ozone depleting substances at the moment are significant potentially, but in the future they can grow into being more significant in their emissions. Production is significant in the amount of emissions it produces in the life cycle. Hydrogen and methane are the most environmentally friendly fuels for future use, and due to their pollution, hydrazine and solid rocket propellant should be avoided when possible. So future work and limitations. There was a lack of similar literature available for analysis and comparison. Exclusion of afterburn was excluded from the life cycle phases. There's a poor understanding of black carbon and alumina particulate for radiative forcing. Global warming as an impact category overestimates near-term climate forcers, and there's a lack of considerations of atmospheric conditions during these launches. So potential improvements: regulation and policy implementation for rocket launches, carbon neutral manufacturing processes. This will allow for near net zero emission rocket launches for hydrogen and methane. And finally, further investigations into other relevant impact categories and more comprehensive analysis. That's all. Thank you for your time.
And another huge congratulations to Anthony Giampa for his project EAF, The Future of Steel Production. And there will be video as well.
Nowadays, steel is made via two main routes, the blast furnace basic oxygen furnace route and the electric arc furnace route. The first one consumes iron ore and coke, while the second one uses electricity and recycled steel. Currently, 30% of worldwide steel is produced by means of EAF process, and as it is shown leftwards, it will tend to grow continuously due to the increase of steel scrap availability, as shown rightwards. Furthermore, for every ton of steel scrap utilizing the EAF process, it is possible to avoid 1.5 tons of carbon dioxide. Moreover, it can be restarted and interrupted anytime due to the dependency on electricity, guaranteeing high flexibility and efficiency. For all of these aspects, it is important to know how EAF process works. It can be divided in 4 phases: scrap collection and preparation, steel melting in the electric arc furnace, matching chemical composition in the ladle furnace, and solidification in the continuous casting machine. Scraps arrive in the plant location and it is divided in different typologies. Then it is inserted and melted down in the electric arc furnace by means of the electrical and chemical contributions. The electrical contribution is provided by graphite electrodes connected to the power grid, and they provide the larger contribution. Then the chemical contribution is provided by oxy-fuel burners to speed up the process. There are 2 outputs: the EAF slag, a rock-like material full of impurities, and the liquid steel. This last one will be poured inside another container called ladle, and it is moved towards the next stage called ladle furnace, where the chemical composition is matched, adding ferroalloys. Then the liquid steel is poured inside another container called tundish, and the liquid steel flows through multiple lines where it will start to solidify by means of water nozzle, and the entire process ends up with the cutting, obtaining the semi-finished products such as billets and slabs. Many aspects must be pointed out, such as the air pollution. Utilize a fast abatement system. Then it is possible to exploit the hot temperature of off gases with a heat recovery system. Multiple breakthrough technology can be utilized in order to speed up the process, therefore abating costs. Anyway, the main drawback of this process is the strong dependency on the market situation. Any catastrophic event can have a strong impact on this sector. EAF process is set to become the most convenient and profitable process to produce steel, not just from an economic point of view, but even from an environmental perspective, reducing more and more CO2 emission and presenting interesting scenarios even for the manufacturing sector.
Well, thank you so much to Lucy. So, unfortunately, our event is over. And thank you so much for being here today with us and for dedicating your time. And of course, thank you so much for everybody following us online. And I hope you enjoyed the 2022 Young Manufacturing Leaders main event. And I just want to remember you that the World Manufacturing Forum Redesign Supply Chains in the New Era of Manufacturing will start shortly in the Agora. And thank you very much. See you next year, of course.